So, hello, welcome back everybody. Let me turn off my stream audio so you cannot hear it. Today we're going to be continuing with, wait just a second, let me turn on the music. Okay. So, hello everyone. Today we're going to be continuing learning WGPU. To be more precise, I'm going to try and cover textures, uniform buffers, 3D camera, and hopefully instancing. But we're going to see, we're probably not going to have enough time for all of them. So, last time we did buffers and indices. Let me open Visual Studio Code. We managed to make a simple program. If we just run this real fast, yeah, which draws a pink pentagon, I guess. So, what are we going to be doing right now is, let me quickly set this up, like this. So let's go to textures. Okay, yeah. Loading an image from a file. Okay, so for this, first of all, we're gonna have to implement dependencies. Can I just dependencies dot image? The version is gonna be the newest version. Features, default features to false, and features are gonna be PNG and JPEG. I don't really know why I need JPEG because I'm not going to be loading it, but yeah, why not? So wait, is this working? Okay, yeah, it is. So, the JPEG decoder that image includes uses Rayon to speed up the decoding with threads. WebAssembly doesn't support threads currently, so we need to disable this so our code won't crash when we load our JPEG on the web. Decode JPEGs. I'm not going to be using JPEG, so I don't need that. So, in the creation of the state, so let's go to our state, find, let me close all of these. Okay, new. After configuring our surface here, let's quickly do this. Here we grab the bytes from our image file and load them into an image, which is then converted into a vector of RGBA bytes. We also save the image's dimensions. Okay, let me quickly get some image in here. Let's open a sprite. Oh. Let's just do paint. Quickly draw something. Let's do a smiley. So grab this. Actually, I think I already have some images, just so I don't waste time on this right now. So a sprite, random stuff. Let's do this, I guess. So let's close of this. We don't need this for now. We're gonna diffuse bytes. It's gonna be include bytes. Is this path relative? The file is located relative to the current file. Okay, so I'm gonna have to do this. Oh wait, I need to make this shuffle play. Okay. So like this. diffuse image. Equal image load from memory. The buffer, create it here already, and unwrap it. So this is a list of U8. Okay, so list of bytes. Diffuse RGBA is going to be diffuse image dot to RGBA8. So then using image, I'm just gonna specify use image here. Generic image. And go here and let the dimensions equal to diffuse image dot dimensions. So this is U32 by U32. Let's see, here we grab the bytes from our image. Okay, now let's create the texture. Texture size. Let me quickly, I am gonna need this later on. Yes, no. I'm gonna need diffuse RGBA. Getting data. Okay, so what I'm gonna do for now is to keep with how we have been writing code so far, is make the diffuse texture here. Is it called diffuse texture? Yep. Diffuse texture. Oh wait, but it's not gonna. Okay, let's just try it. If it's not gonna work, we're gonna change it later on. It's gonna be equal to create state diffuse texture. And this is going to be a call of self. And let's create a new function. Function create state diffuse texture. This is going to return. Wait, what does device create texture return? Let's see. Device dot create texture returns. Oh, just a texture. Okay. So this is gonna return WGPU texture like this. Let's copy this. Oh, and the dimensions, but first this. Here, and the dimensions also here. Okay, so now that we have all of that, we're also gonna need it to pass in the device. So we do device here, and take it as an argument here. So device borrowed of device. Okay. So let's see, so we do dimensions, let texture size is type WebGPU extend 3D. Our width is going to be dimensions first element and dimensions second element. Depth or array letters 1. I don't know what this might be. Okay. The depth of the extent or the number of array layers. I guess because this is a PNG, a simple one, it's just gonna have one depth layer. I guess this can be used for some other stuff. This extend 3D other than just textures. I mean, makes sense. Let our diffuse texture. So we're gonna return. We're gonna be returning, where is it? Okay, device, return device dot create texture. It's gonna be WebGPU. Oh, WebGPU texture descriptor. Size is our texture size. All textures are stored as 3D. We represent our 2D texture by setting depth to 1. Then what is this for? If this is already setting it to dimension. Actually, I've heard something about textures 3D. Never used them though. Don't know what they are about. Okay, MIP, level count, sample count 1, dimension. Okay, so it's a 2D texture, so it's texture dimension D2. I guess there's D1, D3. Okay. Format, WGPU, texture format, RGBA 8, unorm, sRGB. That's a title. That's a name if I've ever seen one. So our usage is going to be WebGPU texture usages, texture binding. Oh, texture usages. So we're going to be binding it, and we're going to be copy destination. Copy dist means that we want to copy data to this texture. Okay. Label is going to be some diffuse texture. Why did they name it like this? Like all the names were different, and all of a sudden they use a different naming scheme. View formats, I guess we're going to be setting that later. Okay, this is the same as with the surface config. It specifies what texture formats can be used to create texture views for this texture. The base texture format, RGBA, okay, is always supported. Note that using a different texture format is not supported on the WebGL2 backend. Well, I'm not making stuff for the web, but still good. Getting data into a texture. The texture struct has no methods to interact with the data directly. However, we can use a method on the queue we created earlier called writeTexture. To load in the texture, let's take a look at how we do that. Okay, we're finished with this. So we're going to be using queue to make a new command, writeTexture. Texture is going to be image copy texture, texture R diffuse one, map level 0, okay, origin 3D 0. I want this origin. Is it? Oh yeah, okay, it's a special type. Aspect, WebGPU, texture aspects. What are there? Plane 0, depth only, plane 2, stencil only. Okay, so this is all. Okay, next we go to the data. The actual pixel data, diffuse RGBA. So we are gonna need that. So here I'm gonna not only diffuse texture, but also diffuse RGBA. Where is it? Oh, down here. Diffuse RGBA is, can I copy this? Nope. Okay, so it's an image buffer of RGBA E8, comma, vector, 3 dots. What? Am I not? Huh. What is this format? To RGBA, this returns RGBA image. Can I just use then RGB WebGPU RGB quick fix import image RGB image, and then in here we return this and our diffuse RGBA, right? Okay, then what's up here? Okay, so this, and that's good. Why does it say image buffer RGBA if this is just a RGBA image? Okay. So our data, this is going to be a reference to diffuse RGBA. Let's do this in a new line. Data layout is going to be WebGPU image data layout offset 0 bytes per row sum. Okay, because it's RGBA, it's going to be 4, because for each color, I mean each, like R, that's 1 byte, G, that's 1 byte, and so on. So again, it's going to be 4 bytes per pixel. So it's going to be 4 multiplied by dimensions dot 0, and rows per image, which is going to be amount of rows, which is dimension. I also gonna my god, dimensions. Maybe it's just easier to, yeah, I'm gonna do it like they did it there. Just copy this out, delete this function, and paste it here. And instead of return, this is going to be our diffuse texture. It's going to be equal to this. Okay. And I'm just going to specify creating texture. Okay, so when we're ready this, we're going to need dimension 1. Right, put a comma here. Texture size. Dimensions. Oh, I misspelled it. Dimensions. Also, let's fix this. Oh, hello. Yep, this is Rust. Rip Van Winkle. That's a name if I have ever heard one. Sorry if I'm a little bit late on your message. Okay, so texture size. Pass in the texture. Let's see what's next. The old way of printing data to texture. Oh, no, we don't need old. Actually, maybe C. Maybe there's something interesting here. Pixel data to a buffer and then copy it to the texture using write texture. It's a bit more efficient as it uses 1 buffer less. Oh, if it's already more efficient, then I'm gonna keep using it. Remember this homework. Thanks for the gift card. Oh, it's... Wait. Is this Mr. R? Let's see. I think this is probably. Yes, no? What do you mean yes, no? Who is R? Wait, I gave you gift card information. Wait, it's not you? Let's see. Yeah, Mr. R. No? You're not. Oh yeah, Rip Van Winkle. That's your Discord user. I didn't know that. Wow. Okay. Good to know. Wait, let me do it like this so I can see both chat and OBS at the same time. Okay. Let's go back. what we're doing, texture views and samplers. Now that our texture has data in it, we need a way to use it. This is where texture view and a sampler come in. A texture view offers us a view into our texture. Wow, amazing. A sampler controls how the texture is sampled. Sampling works similar to the eyedropper tool in GIMP/Photoshop. Sampling works similar to the eyedropper tool. Okay, our program supplies a coordinate on the texture, known as a texture coordinate, and the sampler returns the corresponding color based on the texture. Oh, okay. And some internal parameters. Let's define our diffuse texture view and diffuse sampler now. Wait, let's see, I might need to change the stream title actually. I'm not. Let's see, let's define our diffuse texture and diffuse sampler now. So let's... here. Give us some space. So diffuse texture view is going to be equal to diffuse texture. We're going to be creating our view. Because this is default, yeah. Just a WGPU texture view descriptor and do default here. Our diffuse sampler. Okay, so device dot create sampler WGPU. Oh wait, here WGPU sampler descriptor address mode U. Okay, clamp to edge. That means it is gonna cut off at the edge, from what I remember at least. Clamp to edge. Clamp to border is gonna do it to the edge of the screen border. Yeah. The window border is more correct. WebGPU address mode. Okay, all of this is clamp to edge. Got it. Oh wait. Clamp to edge. Let's copy this. And address mode is the same. Okay, mag filter is gonna be linear. Filter mode linear. And min filter nearest. Okay. Mipmap filter. I have no idea what that is. Filter mode nearest, and everything else is default. Okay, don't forget semicolon. Have you played RDR2, Red Dead Redemption 2? No, I have not played that game. What about it though? To be honest, I never really liked it. Like, I'm not a big fan of story-like games. Like, games which have a story like... I mean, I don't know if RDR has... I don't know how to explain, I just don't like that genre of games, I guess. Okay, the address mode parameters determine what to do if the sampler gets a texture coordinate that's outside the texture itself. Okay, so clamp to edge. Texture, any texture coordinate outside the texture will return the color of the nearest pixel on the edges of the texture. Repeat, it's gonna repeat the texture. Mirror repeat. Okay, yeah. Okay, Rip Van Winkle is an alias of a character in it. Oh. Man, it's sad. I thought that was your real name. Rip Van Winkle. Oh, I guess it's rest in peace. Van Winkle, or no. It's actually his name, Rip Van Winkle. Wow. He's really unlucky, isn't he? The mag filter and min filter fields describe what to do when the sampler footprint is smaller or larger than 1 texel. Oh, that's a textured pixel, I guess. These two fields usually work when the mapping in the scene is far or close from camera. Describe what to do when the sampler footprint is smaller or larger. Oh, okay. Yeah, that makes sense. Like if we scale or yeah, scale up or scale down our image. There are two options: linear, select two texels in each dimension and return a linear interpolation between their values. Nearest, return the texel. I can actually show this here. Linear, linear, and nearest. How do I say this? Filters. So yeah, nearest is better for pixel art, where pixel precision is really needed, while linear is better for normal high definition images. Yeah. But I also think in old games, nearest was used for like everything, like all the textures and stuff, but I might be wrong on that. Okay. Maps are a complex topic and will require their own section in the future. Does it have its own section in the future? I mean, there's normal mapping, but that's not maps. It does not. It has its own. I mean, I have my own plans after finishing this tutorial, I guess. Okay. Mipmaps are a complex topic. For now, we can say that mipmap filter functions are similar to mag-min filter, as it tells the sampler how to blend between mipmaps. Oh. Wait, what did we set it to? Nearest. Wait, did I do this correctly? Yeah. Okay, I guess. I'm using some defaults for the other fields. If you want to see what they are, check the WGPU docs for the other field ones. Let's see. Let's go to the definition. Label, that's explanatory. Level of detail, minimal clamp. Max clamp. Compare, if this is enabled, this is a comparison sampler using the given comparison function. Okay. Must be at least one. If this is not one, all filter modes must be linear. All filter modes must be linear. Okay. Border color to use when address is clamp to border. Wait, you can do stuff like this in comments? What? Wait. Let's see, let's try the comment. This is a very cool comment. What is that symbol? Is it this one? Is it the square brackets that do this? What? How's this done? What? What? Is this normal? What? How's this done? I must know. Wait, what if I just copy this? Is it gonna work? No. Oh, I guess it's some specific thing then for this. What is Black Steve? Okay, hello. If I were to guess who this is, I don't know. I don't have any clue who this could be. Wait, okay. So let's go to our state back, save this. Close this, close this. So all these different resources are nice and all, but they don't do us much good if we can plug them in anywhere. This is where bind groups and pipeline layouts come in. The bind group describes a set of resources and how they can be accessed by a shader. Ew, is that Rust? To be honest, if you didn't find this on Twitch, which you probably didn't, and you just clicked on the link, there's like a 90% chance that you expected this to be Rust. So. And also Rust is a nice language, so. Let's make one of those first. So first let's create a texture bind group. This uses nothing that we have used before except for device. So what I'm gonna be doing is, after we create all of this, here I'm gonna do let texture bind hello YouTube. Wait, can you actually let me see. Let me scale this up. Oh, it's barely visible there. You know what I'm gonna do? Wait, I'm gonna move it to the other corner. So let's see. Dashboard, streaming tools, overlays, added the overlay. Let's just move this to the right. Or would be a better place for it? I guess yeah, right, like a little bit here to the bottom. Okay, yeah, let's try this. So save this. Let's see, does it dynamically update? That would be cool if it did. Yay, it did. Okay, that's a better place, I guess, because I'm not writing that low, so the code will still be readable, and yeah. So texture bind group layout, that's gonna be equal to create state bind group. Amazing name, yes. I'm just doing this all for convenience right now. And this is a call of self. So if we go here, function create state bind group layout is gonna take in a device, reference to device, and return WGPU bind group layout. So let's do device dot create bind group layout. Description is gonna be WGPU bind group descriptor. Wait, WGPU bind group descriptor. Entries, I guess it's gonna go through everything later on, hopefully, because I'm not that smart to understand this. Bind group layout entry, binding at 0, visibility with fragment shader, thank you. I don't know. Oh, type. What is this TY supposed to mean? Is this like shorted version of type? Oh, bind. Wait, what? I have. If this was a short version of binding type, it would be BT. Okay, let's see texture. Oops, I don't need all of those parameters probably. So multi-sampled, that's false. View dimensions. 2D textures, so we're gonna do D2 here. Sample type. It's gonna be WebGPU texture. Sample, texture, sample type. Float. Filterable. True. Okay. After the thank you, there is also count. Let me scroll down. Count is none. What does this count mean? If this value is sum, indicates this entry is an array. Array size must be 1 or greater. This value is sum, and texture must be supported. Sum and type is any other variant, bind group creation will fail. What? No, bye bye, Rip Van Winkle. 27. Were there like other 26 names, or is it just like age number? Probably just age number. Okay. WGPU, our bind group layout. Oh no, entry, yeah. Because we're doing entries right now. Binding 1 visibility again fragment shader ty again, whatever that means. I have no idea what this means. I'd better explain it. Oh, it's Whistler. Why is chatting not software and game development? What? Wait, really? I tried to find like a thing for programming, but I couldn't find it. I guess there's someone for software and game development. Alright, let's see. Can I add this? Let's remove this category. Let's see, soft. Oh yeah, there is software and game development. Oh, yeah, that's better. That fits what I'm doing way more. Yeah, thank you, Whistler. Or just Wish. Wizard, you know. Okay. So the sampler binding type. Filtering. That's it, right? Yep. They should match the filterable field of the corresponding texture entry above. Wait, then what's the point of doing this if this is exactly the same as this? Oh, this is texture sample type. Oh, I'm looking at the wrong thing. Binding type texture, sampler. I guess these two are the exact same then? Because they have to match. Okay. Probably not. Count none. Next is label. Label doesn't matter again. Texture, bind, group, left. Much smaller category with people who actually will care. Yeah, I want people who will actually sorta care. That's enough for me. Okay, so we finished this function. Our texture bind group layout has 2 entries, one for a sample texture at binding 0 and one for a sampler at binding 1. Oh, so like we're gonna be passing in the texture and the sampler, I guess. I think. Both of these bindings are visible only to the fragment shader, as specified by fragment. The possible values for this field are any bitwise combinations of non-vertex fragment computer shaders. Most of the time we'll only use fragment for textures and samplers, but it's good to know what else is available. Okay, I guess it's the same way as we created bindings before this. Wait, where was it? Yeah, something like this, I guess, sorta. Probably, I hope. With texture bind group layout, we can now create our bind group. Again, I don't want to flood this, so I'm gonna be doing it like this, texture. Oh, diffuse. Bind group. Gonna be equal to self. A whole 2 viewers. Wow, you are almost close to being correct, but no. So we create state bind group, pass in our device, and pass in our texture bind group layout. Okay, now let's actually go and create the function. I'm doing this so it's easier to read the code. It might not seem easier, but I tried without doing this and it used to be a pain in the ass to find anything. So I'm trying this now, and so far it at least feels nicer. Texture bind group layout is a reference to texture bind. Oh, I need to do probably. Let's see. Oh, just bind group layout. Okay, bind group layout, and this returns a bind group. Oh, now 3 viewers. Wow. Let's see who's in chat. I mean, 3 viewers. One of them is stream elements, so it doesn't really count. 4 even. Wow, I am just popping off today, aren't I? I guess copy and pasting the stream everywhere helped. Okay, let's see. So create here. We get a device dot create a bind group description WebGPU bind group descriptor. Oh yeah, I keep pressing that key. Bind group descriptor. 5 viewers. Oh my, wait, I need to take a screenshot. I'm gonna send this. Oh wait, you messaged me. 3 viewer. Oh yeah, you are correct. I just have my notifications for Discord off. So yeah. Yeah, I think it was a good idea changing what I'm doing to like software and game development. Okay, it's 4 viewers now, but okay, let's see. So our layout is going to be the texture bind group layout. Just a reference to it. Our entries. Wait, I'm looking at the wrong thing. Am I? Is this the same entries? Oh no, they're not the same. Yeah, they're not the same. Okay. Entries is a borrowed list of WebGPU bind group entries. Let's see, bind group entry. This does not seem good. Why does it not? Oh, I did WGUP. Okay. Bind group. Okay, yeah, here it is. Binding 0. It's gonna be a resource. WebGPU binding resource. Let's give you a texture view. How far diffuse. I'm gonna have to pass those as well. Oh my god, I should not have made this a function in that case. I didn't see these. Okay, I'm just gonna write this for now. Bind group entry. Oh, 2 viewers. Well, and it's like people are gonna probably come and see what I'm doing, but looking how someone is learning something is not the most entertaining content of all time, in my opinion, please. I'm just doing this because after this I'm gonna start work on an actual engine for making 3D games. Let's see, so we need a diffuse texture view, which is what type? Texture view, yeah, it's just a texture view. So it's texture view, and we need a diffuse sampler. I guess this can be the sampler. Yeah, WebGPU, and this control save, import texture view. Oh, I need to select. Probably just WebGPU texture view. And also these two have to be references, and also don't forget the comma here. Let's go up a bit and pass in everything here. So these two, and then also diffuse texture view and diffuse sampler. Okay. Okay, I forgot a comma. That should be it. Missing fields label. Okay. The label is gonna be diffuse bind group. That should be all the errors fixed. Okay, now let's close this function. And also close this. Oh my god, best viewers at some random site. Wow, amazing. Thank you very much for that. Maybe that's where all of the viewers were coming from. Okay, I'm joking, I'm joking. Look at this, you might get a bit of deja vu. That's because bind group is a more specific declaration of the bind group layout. Oh, really? The reason they're separate is that it allows us to swap bind groups on the fly so long as they all share the same bind group layout. Each texture and sampler we create will need to be added to a bind group. For our purposes, we'll create a new bind group for each texture. Now that we have our diffuse bind group, let's add it to our state struct. I would actually call this graphics state. Also, let's not put it there. Let's put it before this, yeah. Diffuse bind group is just bind group. Okay, I just need this. So let me remove all of those, and in self return here, diffuse bind group. Okay, amazing. Okay, let's see what's next. Make sure we return these fields. Okay. Now that we've got our bind group, we can use it in our render function. Wait, is it? Okay. Let's not get distracted. Let's go to the render. So here we set the pipeline, the render pipeline, set bind group. So here, render pass dot set bind group 0 self dot diffuse bind group, an offset of nothing. Set vertex buffer, index buffer, and then draw it. I don't think anything here is changed. Yeah, all the same. Pipeline layout. Remember the pipeline layout we created back in the pipeline section? Now we finally get to use it. Yay. The pipeline layout contains a list of bind group layout that the pipeline can use. Modify render pipeline layout to use our texture bind group layout. Okay, let's see. We create our render layout, and here, let's go to our render pipeline layout, and our bind group is gonna be texture. Oh wait, do I need to do texture bind group layout? Right, so I have to move all of this before the other thing. Okay, let me go here. Where am I creating a pipeline? I'm creating a pipeline. Oh, everything was already placed correctly. Okay, silly me. Okay, so we pass in the texture bind group layout here, and here, except for all of these, we also accept texture bind group layout. Yeah, amazing. So in here we do texture bind group layout. Okay, let's close this for now. We change to the vertices. There are a few things we need to change about our vertex definition. Up to now we've been using a color attribute to set the color of our mesh. Now that we're using a texture, we want to replace our color with text coordinates. These coordinates will then be passed to the sampler to receive the appropriate color. Okay, let's actually don't close that. Okay, so we rename this to texture coordinates. We have a 2D texture, so it's only 2 values. And then reflect this change in vertex buffer layout. Oh, it uses this. Oh my god. So first it's format 32, then it's format 32 by 2. Shader location 1, 0. Offset. Okay, format. It's not new, it's just changed. That is incorrect. Yep. Let's see, so this is float. 32. Okay, it's size of vertex. Yep, seems to work fine. Last we need... Okay, yeah, I am not thinking about how all of this works. So I'm just gonna paste it here. Oh yeah, and as the last stream, the same deal with texture coordinates is like positions, how they're written down. I've explained that before, so yeah. Shader time. With our new vertex structure in place, it's time to update our shaders. We'll first need to pass our texture coordinates into the vertex shader, and then use them over to our fragment shader to get the final color from the sampler. Okay, let's go to our shader. So we input position and text coordinates here. Oops, coords. This is a vector 2. We output texture coordinates here, which is also vector 2. So we set texture coordinates to our model.texture coordinates. Clip position, model position. Let's see. Now that we have our vertex shader outputting our texture coordinates, we need to change the fragment shader to take them in. With these coordinates, we'll finally be able to use our sampler to get a color from our texture. Okay, I get what the binding does, but what does the group do? The variables t-diffuse and s-diffuse are what's known as uniforms. We'll go over uniforms more in the cameras section. For now, all we need to know is that group corresponds to the first parameter in setBind group. Where is setBind group? It's in here. Where we set the bind group. It corresponds to the first parameter in setBind group. Also the index. So if I change this to 1, I'm gonna... Okay. So if I change this here to 1, then this here should also be a 1. So basically it's dependent. Okay. Good to know. Let's go to our shader here. And let's see. So group 0. Binding also 0. Variable texture diffuse. I'm actually gonna do it like this, so it's easier to read. This is a texture 2D F32, but diff is gonna be like difference, I guess. I don't care. Let me copy this again. Var sampler. Oh, it's just a sampler. Okay. And this is the first binding. Okay, let's see what's next. Oh, don't forget the semicolon. In the fragment shader, we return a texture sample. It's still a vec4, so it's still a RGBA color. We'll do texture sample here. It's a texture diffuse, sampler diffuse, and the texture coordinates which get passed in from the vertex shader. Yeah, here, the out. I guess this out and in convention came in from GLSL. Yeah, from what I know, you can just name anything, whatever you want them to be. Variables, t-diffuse and s-diffuse. Okay, yeah, I already read this. If we run our program, 100%, there's going to be an error with the location of the image. It's like going to say that, oh, cannot find file specified at path, something. Okay, let's see. So we did get an error. Was I correct? Oh, it's a parsing error. What did I forget? Do you need our shader? Line 31. Oh, this. Okay. Not what I expected. I need to install like something. Oh, sample. Okay, so many errors are gonna be here. Let's see. What oh, I didn't save it. Oh my god. I really need to install something. Oh, it works. Let's go. I really need to do something. So, like, a language server, I guess, but I did install a language server yesterday. I mean, at least it says that it's a language server. Okay. Let's go to our shader. So it works, yeah. Amazing. We have a texture actually drawing, and we're not even like... Okay, maybe we're an hour into the stream. Let me check. Yeah, we're an hour into the stream, and we have a texture working. The only problem that it's flipped, which is not preferred. Let me just draw all your pictures, I mean all your PNGs upside down. So, what's the big deal with that? That's weird, our tree is upside down. This is because WebGPU's world coordinates have the y-axis pointing up, while texture coordinates have the y-axis pointing down. So, yes, very... I read all of that. With that in place, we have a good facing tree. Do we? Do we though? We don't have a tree, we have a phoenix. I mean, I tried my best to make a phoenix. Cleaning things up. For convenience, let's pull our texture code into its own module. Okay. We'll first need to add the anyhow creator. What is anyhow? I've seen it being used, but I literally have no idea what it does. Anyhow, latest version. Let's create texture.rs. Here we're gonna use image, generic image view, and we're gonna use everything from anyhow. Hi Nakomi, good to see you here. Look at this. I have a full-on texture going on. Isn't this amazing? It's beautiful. So, we create a public struct. Yeah, I know, it's so cool. And it, from what if I understand this correctly, if I go to, let's go, where's the state? Oh, here's the state. If I change these, actually, what will happen if I do this 2, 3, wait, was it 2, okay, 2, 3, and this to 0, 1. I wonder how it looks. Will it look absolutely the same? Yep, it looks absolutely the same. I mean, expected. I don't know why I expected it to look different. But I can like move this to like, let's say 4, and now it's gonna be all wonky in one place. Yeah. So here, let's see, we create a public struct texture allow unused. Why do I need to do that? It's gonna be used anyways. I'm not gonna do allow unused. Okay, so public texture WGPU texture. Then there's going to be the view, which is going to be texture view. Yep. And the sampler is going to be WebGPU sampler. Okay. Let's see. For the texture we implement a few functions from bytes. So we pass in the device. It's a good thing that okay, that doesn't matter. What's a good thing? Bytes U8 label a string reference. This is going to return a result of self. Wait, don't you need two parameters for result? Huh, I thought you always did, like, what's gonna happen if everything cool, and the other one, if there's an error, like, error here. But I guess you don't do this. I mean, you don't, not that you don't do this, you can not do it. So it's gonna be an image, load from memory, bytes. Is this gonna load to this? It's not included anywhere in the module tree, so else otherwise I can't offer. Oh yeah, I need to public mod this. Is it gonna, yeah. Let me go to main, the public mod texture. So I actually found out that my like streaming thing, I don't know how to explain it, was just chatting, and there was actually one for software and game development, so yeah. Okay, so self from image device q borrowed image some label here. For that we also need a function from image, which is gonna device q image. After I borrowed image, dynamic image. So much stuff. Label is an optional one. I wonder why it's optional here but not in the other one. Okay. Yeah, I guess this is doing everything that we did there. Can you just like Control X, Control V this? Let's see, let's close this. Where is our state? Let's go a little bit up. So it's diffuse. So it's RGBA equals image to RGBA. I'm just not gonna copy, I'm gonna rewrite all of this. So RGBA is gonna be image to RGBA 8. Let dimensions equals to this. Basically, our size is gonna be WebGPU extend 3D. Our width is gonna be dimensions 0. Height is going to be dimensions 1. Depth, this is a 2-dimensional texture, so it's going to be 1 layer. Let our texture be equal to device.create texture. Texture description is going to be WebGPU texture descriptor. Our label, our size, our MIP. Level count is going to be 1, our sample count is going to be 1, our dimensions are 2D, our format is going to be texture format, RGB, 8 unorm sRGB. Usage, WebGPU texture, usages, texture binding. So we can use this in shaders and texture usages, copy DST, so we can copy from it, yeah, or to it. Oh my god, let me check real quick. It's up here somewhere before the bind group. Copy this means we want to copy, yeah, copy data to the texture, not from the texture. Okay, let's do Q. Right, our oops. Right, texture, not buffer. Image copy. Oof. Image copy texture. Yep, this is gonna be aspect, all aspects. Texture is gonna be reference to texture. Map level is gonna be 0. Origin 3D 0. Okay, that's it. Then the RGBA here thingy. Okay, I got 2 commas by mistake. Then WebGPU image data layout. Our offset is going to be 0. Bytes per row again. It's multiplied by 4 because we have RGB and A. Each one of those 4 takes 1 byte. And this is going to be the y-axis. Okay. And our size here. Oops. No, like this. Now let's create our view. I think I can just copy this already. Where is this? Yeah, let me copy this. Paste it here. Rename this to view. This to sampler. This to texture. And yeah. And this returns an OK of self, texture, view, and sampler. Okay. Not okay. I forgot to set the return type, didn't I? Yep. Result of self. So now using this, we publicly mod the texture, which we did here. And then in our everything until texture bind group layout can be removed. So okay, then we do let diffuse texture be equal to texture from bytes, device queue, bytes are diffuse bytes, and label our texture. Let me separate this. this is gonna be diffuse texture dot, this as well. Oh, this is just gonna be dot view. That's gonna be dot sampler. Expect unwrap. Why did it expect unwrap? Are these public? Yeah, these are public. Are diffuse texture? Oh, I forgot to do unwrap on this, right? Yep. Dot unwrap. Yep. Okay. So this is fine now. Diffuse texture. We also pass on the diffuse texture. It's gonna be texture. And don't forget to return it here. Don't forget the comma. So now everything works. Okay, so now comes the testing part. Let's see. So this is how we create the texture. We create a diffuse bind group for each texture. Wait, how does it create the... okay. So it only needs the device and it only needs the group. So basically for every new texture, I'm gonna have to repeat this. Okay, so this is how I create the texture. So let's see. If I copy this real quick, let me get some other texture, random stuff. Let's get this. Let's try to draw this texture. Let me copy this. So basically we're just gonna change this to gold tree. Let's rename all of this to 2. Oh yeah. Okay, I'm not gonna do this. I'm just gonna see how it would work for if we wanted to do multiple textures. So basically when we set the bind group, we set the diffuse bind group, which is this. So yeah, basically in the end it's gonna have to be a diffuse bind group for each texture. And when we want to draw some texture, we're just gonna set the bind group. So we basically set the texture here, then we set the vertices. So basically the points of our 2D thing. Then we set the index buffer, so this basically sets what the shape we're gonna draw. This sets the texture for our shape, and then we draw it. Set pipeline sets the shader. Let me even write it this here. So set shader, set texture, and this is set shape. Let me actually move all of these one line before so it's easier to read. So in the end we're gonna need an easy way, after like I'm done with this tutorial, to make shapes, textures, and shaders. Okay. Let's see. Wait, is there someone else watching now? Let's check. There is Penguin Guide. Okay, I don't know who this is, but probably. I don't know who this is. Okay, let's see. Challenge, try to swap textures. Yeah, I'm not gonna be doing this right now. Let's go to uniforms and camera, as this is not very long yet compared to textures. I think we can do this right now. So, how do we do uniforms in WGSL and camera to make a camera is pretty easy. I've done this before multiple times. Like, it's basically the same code for everything. If I go here real fast, include. Yeah, this is basically the code you're gonna use for most of the cameras. It doesn't involve movement like forward, left, and right, but the calculations for upright, front, all of them stay the same. View and projection, the same. I can probably do all of this from memory, but I am not gonna do all of this from memory. I just have this saved in a GitHub repo, so I can access this anytime I want. So let's see. Let's create a new file, camera.rs. Can I actually wait, let me make a new folder, call this lib, put all of my stuff there. Wait, this, put all of it. Put texture here, move, state, move, camera, move, app, move. Here we create mod.rs, where we're gonna publicly mod all of these. Also public mod camera. Then in here, we're gonna be using create. Wait, how do I use this again? Let's see. Use. Do I still need to do like mod lib and then use lib app? Oh, okay, yeah. Found module declaration for. So I don't need to do this. No, I do need to do this. Wait, why does it not like? Warrant special module name. Oh, okay, let me rename this. WGPU lib. Skip changes, please. WGPU lib. This is also WGPU lib. Okay. Here we can just use what was it trying to use again? And can we use super state like this? And the same probably is required here, yeah. Use super texture. What? Can I just do this then? Yeah, okay. We don't need this here anymore. But there's still an error. Oh yeah, I'm gonna have to do this // // Okay, let's go to our camera. Oh, we have to include some new libraries. Don't want to forget about that. Actually, to make this more organized, let me make a textures folder. Put these two there. Yep. So now in textures. Oh wait, no, it was in. I already forgot where it was. Yeah, in state, this has to be textures / like this. Yep, that's good. Let's see, we don't need this, and we don't need this. We also probably don't need app. and this. Yeah, these are the two main ones we're going to be working with. Okay, so now that we're done with cleaning things up a bit, let's do CG Math. And let's start. We create a new struct, a public struct. Why is this all red? Okay. I CG Math point 3 F32 target is gonna be CG Math. Is this gonna be is this gonna be look at? Is it not gonna be normal moving around camera, I guess? Vector 3 also of F32. Aspect F32 FOV. I'm just gonna call this FOV, Z near, and Z far. This is basically how close to our camera and how far from our camera we can see stuff. FOV is if you ever played any multiplayer game, I mean not multiplayer game, ever played an FPS game, field of view. Aspect is aspect ratio. Up is where our app is, like literally. So in this case, because the y-axis is up in WGSO, it's going to be 0, 1, 0. Target is where we're going to be looking at, and I is the location of our camera. So let's implement for camera. Function build view projection matrix. What I like doing is usually CG Math matrix is saving them as well. So here I'm gonna do view projection. Which are gonna be CG Math matrix for just a personal preference I like to do. Okay. Because what if we want to build it once and then just get access to it everywhere? Why would we want to like rebuild it for every time we want to get access to our variable? In this case, a view projection. Not very efficient. CG Math, perspective, SG Math to degrees, self FOV. Wait, this gets it as degrees. An angle in degrees. Oh, then degrees is way easier to handle than floats. So I'll see later on. Maybe I'm misunderstanding this right now. So this is self.aspect, self.z near, and self.z far. And return our open GL to WebGPU. What is this? What is OpenGL to WebGPU matrix? The build view projection matrix. Okay, yeah, this is just math. I've actually spent a lot of time trying to understand that math a while ago. It's not actually that complicated. Okay, let's see. What is this? We don't explicitly need OpenGL to WebGPU matrix, but models centered at 0, 0, 0 will be halfway inside the clipping area. This is only an issue if you're using a camera matrix. Rust FMT skip. I do not know what that is. But let's see what Rust FMT skip is. Rust FMT skip. How can I switch off Rust FMT? for a region. Okay, let's see. What is Rust FMT? Format Rust code. Oh. Let's see. Rust FMT, a tool for formatting Rust code according to style guidelines. If you'd like to help, okay, I got it. I am not gonna be all of this, so I'm just gonna copy this, some constant. Let's see. So it screams at a lot of stuff. Yeah, I'm gonna do this. So it was Rust FMT skip, something like this, right? Did I mistype something? Nope. Oh, it just checks that it's unused. Well, it's gonna be used soon. So in our state, we're gonna be, I think it's still better to rename this to graphic state, but I'm probably gonna do this after I make the camera. So here, where would be a good place for a camera to be? After the surface, because they're related. So this is gonna be camera, but implemented, so super camera all. This. Create a new camera, let camera, type camera I. Position the camera 1 unit up and 2 units back. Okay. What does it do into? Oh, yeah, I know what it does into, because it's a different type. 0, 0, so it's going to be looking downwards. We're going to specify up, which is CG math vector 3 unit y. Doesn't this just return? Yeah, this returns what I said. So 0, 0, 1 to specify the y directions up. Why do this though? I don't know. I could have probably just done a normal vector there. Okay, let's see. Aspect. We configure width as an f32 divided by config height as f32. Field is private. Did I accidentally make this private? Oh, all of them are private. Wait. Oh yeah, I forgot to make them public. Let's copy this real fast. Okay. Now that all of them are public, yep, those errors should disappear. FOV is going to be 45. 45. Okay, so I guess it is in degrees, isn't it? Okay. So Z near. Actually, no, it does make more sense to make it FOVY. Yeah, because those are different things. I should not confuse them. Like this. Yep, good. So there is Z near, there is Z far, 100. And then after the surface, we return our camera. Okay. Not okay. Missing structured fields. Oh yeah, this is an option. Which we're gonna be specifying here. So then we just have that view projection equals sum of this. And then we're just gonna return a reference to this. Nope. Dot unwrap. Okay, what's the problem with this? Cannot assign to self. Oh, borrow self is mutable. Okay. Fix the mutable problem. So this should be the camera done. It's still missing the struct, so I just need to set this to none. Okay, that's good. Let's see what's next. The uniform buffer. Okay, so this is where we're going to be setting our view projection of the camera. We're also going to be probably changing the shader a bit to... Where's the shader? We're probably going to be multiplying. So here we're going to be passing in MVP. Actually, I don't know how uniforms work in WGSL, so I'm not going to do this right now myself. Let's just read through this real quick. So you need buffers to store vertex and index data. Using only buffers is not very comfortable. For examples like this, we just want to sign in a view projection. In this case, it's better to use uniforms, yeah. What does it do here, though? Oh, it wants to make structs. Can you do it without structs? Probably. Just syntax sugar, I guess. So represent as C. We're gonna derive a few things. Debug, which means all of this is debuggable. We can copy it. We can clone it. We do byte pod and byte mark zeroable. So here, struct camera uniform. Can I type struct, please? Oh my god. Camera uniform. Our view projection is going to be F32 4 times 4. Okay. Let's implement for our camera uniform. Function new, it returns itself. I'm going to be using CG math here. I guess it's fine if we use it here. And we're going to return a self of view projection, CG math, matrix for identity dot into function update view projection, borrowed mutable self camera, or reference to camera, self.view. I actually can see why we would use this as a struct. It allows us to use wait, I didn't make this public, didn't I? Yeah, I didn't make this public. This allows us to use different functions on the actual uniform, which is pretty nice in some cases, like this one, when we need to constantly update it. Instead of doing like in our main loop or something, we can just write something like this on the side. Why is camera... Oh yeah, I need to do it mutable reference. So after we create the camera, we need to create... Let me close this. We need to create our camera uniform. So it's going to be a mutable camera uniform. Camera uniform.update view projection. Okay, so we need to create it as a mutable camera. And let our camera buffer be equal to device create buffer initialization. Let's see WGPU. Utilities, buffer, and then descriptor, label, some camera uniforms buffer. So we still need to create a buffer for the uniforms. Okay. Contents, byte mark cast slice, the same thing we did for vertices and indices. Camera uniform. Oh yeah, don't forget the usage. This is going to be used as a uniform, and it's gonna copy buffers to it, not from it, but to it. So it's a copy destination, not a source. Okay, so we still need to create like bind group layouts for all of them. Okay. I guess we just need to create this before all of this. Like after this would be a nice place, yeah, like here. So, let's see, let camera, wait, why did the music stop? We have listened through the entire playlist. Oh, I should really add more songs here. But okay, let's restart, I guess. No one has been here for longer than 1.5 hours. Did I do shuffle play? Yep, I did do shuffle play. Okay. So camera bind, group, layout. It's gonna be device.create bind group layout. Reference to WGPU binding this descriptor basically. We're gonna have multiple entries like we did when creating the bind group layout for the texture. I mean, makes sense. They're the same type, buffer, group. Oh, it's a bind group, okay. Layout entry, it's gonna be our first binding. Our visibility is gonna be only usable in vertex. Oh, interesting. So that means that each group, like, wait, let me open the shader. That means that this group is also binded. So we can use group 0 if we pass to the vertex shader. It's gonna work fine, but we cannot use group 0 twice for, okay. I think we're gonna see later on. So visibility, it's a vertex type, WGPU binding type, buffer, TUI, buffer binding type, uniform, has dynamic offset false, and minimal binding size none. Then after all of this, our count, not here. Oh, I skipped over one. Count, also none. In the end, our label is going to be sum of camera bind group layout. Means that the location of the date has dynamic offset. Means that the location of the data in the buffer may change. This will be the case if you store multiple datasets that vary in size in a single buffer. Okay. Well, our data is always going to be a 4-dimensional matrix, so we don't need this to be true. Now we can create the actual bind group. Let camera bind group be equal to device dot create bind group WGPU bind group descriptor, our layout, camera bind group layout, entries, bind group, entry, need to pass this here. So it's gonna be camera bind group layout type bind group layout. So now with this we also need to set it here, so put a comma. Wait, let's make it like this so it's more readable. Camera bind group layout. Okay. This is good, this is good, this is good. Now we need to add camera buffer and camera bind group to state. And not only that, we also need to add the camera uniform. Maybe camera uniform, camera buffer is going to be a buffer. I'm actually going to move this up with all the other buffers, just put this before them. And bind group here, camera bind group, right? Right, this is a bind group. Oh, how is it there? I do not know. Let's see now in here, we need to set the camera uniform. Before the vertex buffer, we set the camera buffer. And after this, we set camera bind group. This should be all of it. Wow, there's a lot of stuff in our state struct is there. So now in the rendering part, where is this? Where is this? Where is this? Oh, this is creating render pipeline. Wait, I need to close this. Render. Okay, here. So I set the pipeline. Okay, everything seems to be the same. Set camera projection render pass dot set bind group. Oh no, the index is 1. Okay. So even though they're in different shaders, they still have to have different. Even though they're in different stages of the shader, they still have to be different group IDs. Okay, so now we go to the shader and we do. Wait, that's not the shader, that's the camera. And here we create a new struct. And yeah, I will do it here. So it's a struct camera uniform view projection. Usually people call this MVP. Wait, no, MVP is when we also multiply, yeah, it's model multiplied by view projection, so this is not MVP. Model is basically another matrix, four-dimensional matrix, which contains position, rotation, scale, and etc. in it. So here we need to create a group. This is group 1, binding 0. It's a variable of type uniform, camera uniform. And then in our VS main, clip position is going to be camera.view projection. Okay, this is already MVP, I'd say. Yeah, I would not call this clip position. I'm gonna call this... actually, no, I can't call this. That's sad. Because it is clip position, it's just position. Yeah, okay. Let's see. Let's run our program to make sure there are no errors before we continue writing more code. Okay, seems to be working. Camera controller. And I can just copy and paste this, right? Yeah, I'm just gonna process events. Oh, I'm gonna need to open app here. Because we're gonna have to call process events here. So our abstract. Okay, fine. I am gonna copy all of this though. I am not gonna be writing all of this down. Sorry. This is a simple WAST controller. Let's see, this is not window event, but this should be key event. Okay, I'm gonna have to match event, move this back, so it still needs to be closed like this. Okay. True, everything else is false, so that's if nothing happened. Then in here, are there any problems? Seems like there is. Oh, maybe not enough. Let's see. So this to this, this to this, this to this, this to this. Does it do physical key? Oh. Event dot physical key. Okay, I need to import this. And I need to import this. Because now I need to do when key, logical key. Okay, physical key. So if I do this as physical key, I'm gonna have to do physical. I'm gonna need to implement physical key code. Let me implement this and just copy and paste this everywhere. There's probably a better way of doing this, but for now I'm gonna do it like this. Is equal. What is this? Is forward pressed. All of these are always going to be set to true though. Oh, but then I'm going to have to set them all to false here. Yeah, I should have just done it a different way, but fine, I'm doing this as quick as possible. I'm not going to keeping this camera movement for long. All these are going to be set to false. Okay, it does fall through, so that's good. Either it returns false. Okay, okay. No errors, that's always good. Then in our state, we're gonna create camera controller. It's gonna be a camera controller. And that's weird. Why does it? Oh, I need to make it public. I forgot about that. Oh, I'm gonna need to have to make everything public. This public, and this public. Yep. So let me close all of this. Okay, so you do know this. And we'll create a new camera controller. Let's make this after we set up everything for the camera. Let camera controller be equal to a camera controller. A new one with the speed of 0.2. This is speed, right? Yeah. And then we just return this after create it. Okay, now we go into our input function. My windowing is different from here. What I did was that for window event, so window event, keyboard event, if it's a pressed key, we go here, and so we check if event is equal to what? I forgot already. If it's equal to element state pressed. Oh wait, no, I already checked this if it's pressed, right? I think I have. Keyboard input, public key event. Oh no, I don't. Okay. Is this fine? No. And element state mismatch of events. Oh, I hate Winit. Winit is absolutely awful. Okay, so part of the key event. Physical key, logical key, state. Okay, so if event.state, for example. Okay. Then we do self.state dot camera, wait, We need to make the camera controller public. Where is our state? So we can access it. Camera. What? Why does it say that none of this is being used? Just a second. Okay, so we set up the camera controller. Oh, do I need to do .unwrap .camera controller? Okay, and I do process events and event. Cannot move out of self state. Okay. Nope. State. Dot. Oh wait, no. Do I need to do it here? Dot as mutable. Okay. After this. No errors? Really? Okay. So in the update function now. Which is also here. So that I'm gonna also need to make the camera public here. Okay, so let's see. We do the same strange code here. So we do self.state, we borrow it as mutable, we unwrap it, we get our camera controller, dot update camera with a mutable reference to our self-state unwrap dot camera. Yep, I love Rust. Quick fix. I already did a quick fix. Oh my god. Wait, I don't need to do as mutable here. Right? Cannot move. Let's see, does this weird line of code work? Nope. Actually, itself. Nope, it does not work. Man, real Rust moment. Let's see, I'm gonna go full screen mode for this. So, an easier way of doing this would be maybe moving. What is the problem? You could clone the value and consume it if the state. So just, but I can borrow it as mutable. But I cannot do a reference twice. Then expected mutable camera found camera. Then I grab this as no, I cannot dot clone. No. Dot borrow mutable. Cannot borrow self state as mutable more than once at a time. Oh my god. My brain is about to explode. Okay, wait. This reminds me so much of something that I just saw recently. Wait, where is it? Yeah, this reminds me of this. Okay, let me open this meme. Wait, can I make it? Yeah. Oh, it's not very readable. Wait. Can I scale this up? Wait, let me select all and scale this up. Nope, I can't. Wait, let me scale this up and select all. All. No. Oh my god. Basically, this is the meme. Yeah, it's hilarious. I know. Basically, cannot borrow variable as mutable more than once. It's already borrowed once. The second, yeah, this is the exact same thing that is happening to me right now. It's mutable more than once at a time. So how do I go about it? What if I put let mutable var equals self dot state dot as mutable dot unwrap? Right? Can I then use this variable? It's probably not gonna work, but who knows? It does work. Okay, let's just change this name to state mute copy. Wait, would I just be able to use clone? Dot clone, nope. Would I be able to use dot clone on this? Nope. It's probably not gonna work later on. Not gonna lie. What this meme? It's a very hilarious one. It's wait till it's showed again. Let me just open it in Discord. This one. Basically, when you try to borrow as mutable a variable multiple times, Rust does not allow you to do that. And I just have the same issue right now in trying to fix it. Okay. So let's see what's next. Oops, let me here. Self.camera uniform. Oh, we also need to make it. Oh my god. You know what? Let me add a few functions to this. Let me add public function input, which takes in a parameter of self and what and an event. Okay, then let me make a public function update, which takes in just a mutable of self. And let me go to here. Let me just do self.state dot unwrap. Wait, how did I already access state at some point? Oh yeah, I still need to do as mutable. Dot unwrap dot input, and the event. Oh, I need to do it as a reference to the key event. Don't forget this here. So that's gonna happen. It doesn't know what this is, that's fine. I'm just gonna import it. And also, then after this, I'm gonna call self-state.as mutable.unwrap.update. Does it allow me to do it in 2 different lines? Okay, it does. So I call the update function. And now I can remove all of this useless stuff. I can make this private again. I can remove this. Okay, no errors. Then I go here and I start checking stuff. Where is our input? So check if event.state equals element state dot pressed. Oh, pressed. Then in that case we're gonna do self.camera controller dot process events. Oh, double equal. Always happens to me. Okay, so this is the input, and in the update we do self.camera controller. We update the camera, mutable reference of self.camera, self.camera uniform dot update view projection with a reference to camera, self.q, write buffer, self.camera buffer, 0, data is a bytebug, cast slice of reference to self.camera uniform. Let me just copy this. Update view projection. Oh, why does it? Oh yeah, I know why. But it's fine, I can do this. Okay, let's see, will it work? The camera controller, when it processes events, it does key WASD, okay. So let's just clear this and do run. Oh, cargo run. Let's clear again. Cargo run. No compiler problems, yep. Yep, some camera, working stuff. Yep. I don't like how it takes time, like I can't just hold. For some reason it like stops for a few seconds. It feels weird. Okay, this is good camera stuff. I like this. Okay, so now, yeah, I guess that's it. At least for today, that's it. As I have been streaming for 2 goddamn hours. Jesus. I would thank everyone for coming today. More people than usual joined today. I think I got a tops of 5 and actually 2 times. So tomorrow I wanted to do instancing today, but sadly I'm not gonna be doing it as I'm already tired. And oh my god, it doesn't seem that long though. Should I do it? Someone who is still in chat, should I do instancing right now? Doesn't seem to be that long, right? No, I'm not. I'm not gonna do it right now, no matter what you say. So thanks everyone again for coming. There were a lot of people today, as I already said. And yeah, see you tomorrow with instancing and the depth buffer. It's gonna be fun, as usual. Thank you, and have a good day.